All right. Thank you. Hi, everyone. And like Quincy said, I'm just going to talk a little bit today about some new data types in HDF5. So starting off, we have 16-bit floating point data types. Support for these was added in the 1.14.4 release, and this was something that we started looking at as HDF5 started moving towards exploring, machine learning applications and things of that nature. And so when I say we added support, it really means we added support for this float16C data type if the platform has it. And it's important to note that you could already create 16-bit floating point data types in HDF5 before, but by adding in this support, it allows for much more efficient I/O on these types of data types and much more efficient conversions of that data. So, for example, you would be able to read 16-bit floating point data directly into memory instead of doing what applications often do now, which is converting to float on read, which can be a lot less efficient. We also added some configuration options to disable support for this type if you need to. And this is because some compilers and platforms, mostly Clang on Mac OS and then one API in Windows, some of them have a bit problematic support for float 16, and sometimes you can run into problems with building the library. So I listed the CMake and Auto Tools options here to turn off that support if you need to. But by default, we build the support into the library if we detect it. So the format that we're supporting for these data types is just the IEEE format that I linked to here. Of course, it's got 16 bits of storage and 1 bit for the sign. And then the IEEE format has 5 bits for the exponent and then 10 bits for the fraction. So with the support, we added in some new macros to the library. This H5T native float 16, this macro maps to the ID of the data type for the float 16 type. And if you have support on your platform, this macro will be available. Otherwise, it maps to an invalid ID, and you shouldn't use it in your application. And then we also added 2 other macros here, which are standard data types for float 16 data types in little or big Indian order. And these data types are always available, even if your platform doesn't have float 16 support. We also have a couple new feature test macros here. This H5 have float 16. If you have support for the float 16 on your platform, this will have the value 1, and it lets you know if you can use the native float 16 macro above. And then we also have a macro here that just has the size of the float 16 type. Otherwise, it'll have the value 0. And then as far as data type conversions go on 16-bit floats, we added pathways to convert between float 16 and all the usual C types like float and double, int, long, and so on. And these are generally faster pathways, but they're only used if your platform supports float 16. Otherwise, the library just falls back to slower functions that emulate these conversions. And it's useful to note that these conversion paths are just defaults. You can add in your own paths with this H5T register function, or you can even remove these conversion paths if you don't want them for whatever reason using H5T on register. And a final note, you may have to specify some specific compiler flags when you're building the library if you want to get the best performance out of converting float 16 data. Otherwise, compilers may generate conversion functions that promote the data to float first, and this may be less efficient than you could otherwise get. And just a few final notes for the float 16 stuff. We added support for the predefined data types to H5dump, H5ls, and then H5diff in its parallel version. Also added support to the Java wrappers and then the high-level library for use with the text-to-data type and data type-to-text functions. Next, I want to talk about complex number data types, which is something that's been asked for a very long time now. We currently have this PR that I linked to here. Support's currently under review. Some discussion still going on there and possibly some changes. And the last that I heard, I think we're looking at around a January release for adding the support in. And support for complex numbers just maps to the usual C data types that I listed here, the float double and long double with this complex keyword. If you're on a platform with MSVC, they're actually this F complex and D and L complex. One of the most important things to note about this support, though, is that it uses the new data type class here, H5T complex, and a new version of data type encoding that goes in the file. So any complex number data that gets written with these new data types won't be readable by older versions of the library, which is currently the 1.14 versions and earlier. So if you want to keep your complex number data compatible with older versions of the library, you could try using one of these formats that are documented by this NC Complex project that I linked to here, which covers how various projects have come up with their own conventions, and this project tried to standardize between all of them for the good of the community. And right now, the complex number types that we support have to have the same data type for both the real and imaginary parts, and we only support the rectangular form of complex numbers at the moment. But we did add some infrastructure to the file format to try and maybe support other different forms in the future, like polar forms of complex numbers, and possibly supporting having different data types for the real and imaginary parts. For example, you could have float for the real part and float 16 for the imaginary. So like the 16-bit floats, we added in some new macros here. There are native macros for the float double and long double complex types, and these just map to the IDs of data types representing those and the matching MSVC types if you're on one of those platforms instead. And then we also added in some standard types here for complex numbers made of two floating point values that are either 16, 32, or 64-bit and in little or big endian order. And these standard data types are always available even if your platform doesn't have support for complex numbers. And some more macros, just feature test ones. We have this have complex numbers macro. It'll be defined if you have complex number support. And then there's this have C99 complex numbers. If have complex numbers is defined, but this C99 version isn't, that means that your platform's using the MSVC types instead. Just something that may be useful to some people. And then, of course, we have these size of macros for each of the complex number types that'll have their size if you have complex number support, or they'll just have the value 0 otherwise. Along with these macros, we added a new API function as well, this H5T complex create, and it just takes the ID of a base floating point data type and then creates a complex number from it and gives you that ID back. And here's just a simple example below of creating a complex number from the native float type on the platform. And what you get back from this would be just the same as this native float complex macro if you have support for complex numbers. Data type conversions on complex numbers. We added pathways between different complex number types and also between complex numbers and all the usual C types as before, including conversions between float 16. And again, these are faster paths, but they're only used if you have support for complex numbers. Otherwise, they just go back to slower versions in the library that emulates the conversions. And again, these are just defaults. You can override them if you want or even remove them. And I just mentioned briefly here, all these new conversion paths just follow the C standard rules on this. So if you convert a complex number to another type, each of the parts of the complex numbers are converted according to C standard rules. And if you convert a real type to a complex number, the complex number's imaginary part just has a 0, and the real part is converted like normal. And if you convert a complex number to a real type, the imaginary part's discarded and the real part's converted like normal. There's another special data type conversion pathway that we added because of this problem here. Since HDF5 hasn't had official support for complex numbers up until now, a lot of projects have had to come up with their own conventions and formats for storing this type of data, and none of these conventions were really standardized upon. If you actually go back and look at that NC Complex project that I mentioned, you can see there are about 13 different conventions that people have come up with over the years. So we wanted to make it fairly easy to read some of that legacy data without really having any overhead. So this special data conversion pathway allows for these no-op conversions, but it's according to very specific rules that I chose to try and match some of the compound data type conventions that people came up with. And hopefully this will allow people to have efficient IO on some of this existing data that was written by a lot of different projects, including H5Pi and GDAL. Unfortunately, the pathway doesn't really cover some of these projects that chose to use extra dataset dimensions or even different datasets to represent complex numbers. But hopefully with this, first infrastructure for complex numbers in place, the situation may get better going forward. Here I just quickly list the rules for this conversion pathway. If you're converting between complex numbers and an existing array data type, it has to have exactly 2 elements, and they have to have the same floating point, type as the complex numbers base type. And then compounds are fairly strict. They have to have exactly 2 fields, and again, both of the fields have to be matching floating point types with the complex number. The structure can't have any padding whatsoever in it, and they have to have names according to these rules here, and they have to have appropriate offsets in the structure. And this notation I put here just means that the structure fields can have a name that's any substring of the word real or imaginary, and that just tends to match up with the conventions from what the NC Complex project noted. As some people, when they came up with these conventions, some people chose to use just R for the real part, some used the word real or just RE. So in this way, we can hopefully match a lot of different conventions. A couple other things. As far as tool support goes, we added support to H5dump, H5ls, and again, H5diff in its parallel version. By default, the data values just get printed out in the typical A plus BI format. And then I just wanted to note here that H5dump has this -m option that you can use to change how floating point values get printed out from H5dump. And it was updated, so it now also applies to complex numbers. And I just put a quick example here of a test data set with complex numbers and what this looks like from H5dump. Also created some example programs just to try and show how to use complex numbers. I don't have the links to these yet because the PR is still under review, but this is the path where they'll live under the source code whenever that gets merged. So I added an example of using the C99 types, the MSVC ones, and then also an example here of using the new API function that was added to create your own custom complex number type. And then I just added a quick example here to show kind of what this looks like, creating a data set that is made of complex number elements where they're made of 2 32-bit little endian floating point parts, and then using this native float complex macro to write this float complex buffer to the data set. Just the miscellaneous things. Fortran support's planned. It's not currently implemented, but we're wanting to do it. It's just really a matter of funding and interest from the community on it. Added support for the complex numbers and the new API function to the Java wrappers, but since Java doesn't have any official support for complex numbers, it's a fairly limited use, though you could still use them. You just have to be careful with what you're doing. And then I also, again, added the support for these complex numbers and the new API function to the high-level library for using with these text to data type and data type to text functions. And then finally, I linked here a GitHub discussion about some features around complex numbers that haven't been implemented yet, but we're looking at it. Some people have expressed interest, but this generally includes things like data type transformations, filtering the data using, say, the scale offset filter, just kind of things around this that people want, but we didn't really have time to get to yet. And finally, I just want to talk about some other data types that we kind of considered while we were going through adding support for these other ones. So depending on interest from the community, here's just some of the data types. A real Boolean data type is something that I think has been asked for before. HDF5 doesn't really have support for a true native Boolean type. And so if you want to store Boolean values efficiently on disk, you kind of have to do a little extra work to get a data type according to what you're trying to do. So it'd be nice just to have native support to make it easier for people. Another type we looked at is this bfloat16 type that was developed by the Google Brain project. It's another 16-bit floating point format that's more useful for machine learning applications. And this is the format here. Of course, again, 16 bits of storage and 1 bit for the sign, but it has 8 bits for the exponent and 7 bits for the fraction. And this tends to help speed up machine learning applications. We're also looking at 8-bit floating points. This is something that is becoming more common, especially with NVIDIA and GPU applications. But as I note here in link 2, there's a couple different formats in use, including one where 4 bits are used for the exponent and 3 for the mantissa, as well as 5 for the exponent and 2 for the mantissa. So we may have to discuss, which formats are useful and which we want to support. And then just kind of a notable mention here, there's this FP16 type, which is basically an alternative to float16. It's the same format and everything, but this type is only for storage purposes. Any operations you do on it get promoted to float first, so they're generally less efficient than float16, but it's worth noting here in case somebody may find it useful. And then, of course, if anybody is interested in any other sorts of data types, let us know. And just, I posted a couple links here for people interested in looking at the process we were going through when we first started adding support for these data types. I linked the original and the updated RFCs here. And then we also have this forum post that's still kind of ongoing with discussions around things around complex numbers and, nice to haves that people are talking about. So it's worth going there and adding any discussions that you have. And then finally, just a slide here, just talking about how you can support our mission and also probably help support adding some of those new data types. So thank you. Any questions?
Thanks, Greg. Any questions here or remotely?
Yeah, let's make sure to not talk to microphones.
I'm just wondering what was the really use case with such complexity in data type conversion, converting complex numbers to real application and easy to do it, and should be done on purpose, so it's not a mistake that people reading from complex type to state makes it real. And second question is, once again, complexity in power format to support different forms of complex numbers. But then only complex number because the goal of that is much wilder for some quadrillions or whatever. So you're kind of opening Pandora box for more complexity without maybe there is a good use case.
Yeah, sorry, the room's audio is really hard to understand, but I think I'm guessing the first question was about why we have the special data type conversion pathways. Is that correct?
Yeah, especially the complex to real.
Yeah, so there's definitely a lot of ongoing discussion around why we have these data type conversion pathways, especially on that forum. There was a question asked about, or actually, I think it was the GitHub pull request about how people may, run into issues with these conversion pathways because they get unexpected behavior on conversion because they accidentally did something in their application. And I mean, in my opinion, it's nice to have all these by default because when they're in the library, it can generally be a lot more efficient than if people are adding their own outside the library. In the future, hopefully we can make that better, but I feel like being able to, let me go back a few slides here. Being able to, unregister them, I feel is a fairly easy solution to getting back the behavior people want, where the library throws an error if you don't want a particular conversion pathway. And the fact that you can override them if you need to with your own is also useful. And again, support for the complex numbers hasn't been merged yet. It's still open to discussion, and we could always remove them. But I personally feel like they're fairly helpful to have. So, add your discussion to the PR for sure.
And again, that's kind of mimicking what C does. This type conversion is what C does. Standard says.
Right. But no, absolutely. If people feel differently, discuss on the PR and the forum, GitHub, and we can talk about it.
And I think was the second half was why just complex and not the full scale n-dimensional quaternion.
That is definitely a question that I feel like would be better for community, just because I could talk about that forever. Um, and that was also definitely brought up in the forum. And the main reason for that, I think, is that we need a bit more infrastructure in the library to nicely support those. And this project was somewhat time limited, and I wanted to get these out the door to try and let people make use of it, especially with the NISAR satellite project coming up. It would be nice to have support for complex numbers fairly quickly. Um, but that forum post I linked to definitely had a lot of discussion on the higher order types and in dimensional, complex type values. So I think that's something we definitely want to look at. We're not really settled, I think, on the format yet, but for sure that's going to become very interesting.
Yeah, I think one of the baselines that we came back to a number of times was, well, that's what C supports. We can at least support what C supports and then consider our own text.
Right. And I think really one of the things that looked really nice, one of the suggestions on the forum post was that being able to tag in memory data types with HDF5 attributes would go a long way towards supporting this case. And basically, HDF5 would have to determine and document its own conventions on what data types with certain attributes represent in terms of complex numbers or higher order values. So that's the kind of extra infrastructure in the library that I think we need and would take a bit more work and thinking about to develop, but it's definitely a good future project.